Oh, ladies and gentlemen, come gather round, come gather round, come gather around. Today, we're going to look at electronic fuel injection. Oh my gosh. And we'll look at basically 4 parts of it. Where does it get its information from? How does it process that information? What does it do with that information? And why is it so awesome? In the previous video, we talked about carburetors, old school technology. And if you have not watched the carburetor one, I strongly recommend go back, watch it. There's a link up here which will take you back to the carburetor video. I recommend watching it. It uses terms that are fuel injection terms. And I do that so that when we get into fuel injection, you're already kind of aware of what's going on fuel injection wise. One thing you need to know about EFI is that it is entirely electrical. And all the things that we used to run a carburetor need to be turned into electrical so a computer can figure out what's going on. Not everybody likes electrical. It's a little harder to figure out what's going on because you can't actually see it. Everything that the carburetor had to look at to figure out what kind of fueling you needed, all of that needs to be turned into something electrical so a computer can calculate it. The fuel injection computer is going to look at 2 different areas. 1, it's going to look at your environment, and 2, it's going to look at mechanical stuff. Since everything is electrical and we need to look at these in an electrical kind of way, there's kind of 3 ways that a computer looks at things electrically. 1 is variable resistance. Another is variable voltage, and another is a voltage pulse. One time my brother was washing his car, and he had the garden hose in his hand, and the garden hose went over there, and I'm the typical older brother. While he was washing his car, I kind of kinked the hose a little bit to resist the flow of water to wash the car. And I made it slower and slower and slower, and the flow of water became less and less and less, until finally I had this thing completely kinked and no water would flow at all. And my brother, bless his heart, looked at the end of the hose. And that's when I let the water go. Now all the water rushed through towards my brother's head and I got in a lot of trouble. But what I did is I resisted the flow of water. I can resist the flow of electricity too. So let's look at some things in the environment that we need to know, that we need to measure, that might vary. What are some things that change in the environment that are going to affect our fuel? Yep.
Well, probably the engine temperature.
Okay, let's go for it. Engine temperature, it kind of fits this. I mean, the fuel system is being infected by the environment of the motor. It does also kind of fit there. Let's put it here for now. So we've got engine coolant temperature. Engine coolant temperature just looks like this. Let's have a close look. If I were to draw this as an electrical symbol, it's going to look like this. It's kind of like a twisty road. And we're like, hey, that could be fun, but I'm probably going to have to slow down, which is true. And what this is going to do is slow down the flow of electricity through it. However, it's got another wonderful new feature, which is going to do this. And now this line through it means it varies. A resistor affected by temperature is called a thermistor. All this does is give a different resistance reading for the computer. And so the computer's like, oh, you're at this temperature. Okay, we'll fuel accordingly. Oh, you're at that temperature. Okay, we'll fuel accordingly. So that it needs to know temperature. We turn temperature into a resistance, and then we talk to the computer with it. What's another thing in our environment that we need to see, something that changes? Yep, the temperature outside. Yeah, that's definitely our environment for sure. If we want to know what the temperature is outside, we probably want to measure the air going into our engine. So let's look at intake air temperature sender. That's going to work exactly the same as this one. It's a variable resistor. In fact, some people even use the same one. There may be better ways, faster acting ones, but it's a variable resistor. Oh, it's cold outside, more fuel. Oh, it's hot outside, not so much fuel. Oh, it's a really cold engine, lots of fuel. Oh, the engine's hot, not so much fuel. The engine's hot, but it's cold outside, a little bit more fuel, and so on. It just needs to see what's going on with those. What else happens outside? Some other thing we're going to measure outside. Think about the example we gave in carburetors on Calgary versus the Okanagan versus Vancouver. Yep. Air pressure? Nicely done. What was the fancy thing that we were measuring when we were looking at air pressure inside the carburetor? Close? Yep.
Manifold absolute something, something, something.
Manifold absolute pressure, yes. So we're going to have a MAP sensor, which measures part of environment, talks to the computer. This is an example of a manifold absolute pressure sensor, a MAP sensor. It has an electrical connection on one end, and it has a little plug-in with a little O-ring to seal it all up. So this thing measures just the air that got into the motor. This is going to act like a variable resistor, not by temperature, but by pressure. The MAP sensor has 3 wires. One's going to go to 5 volts, one's going to go to 0 volts or ground, and the other one's going to talk to the computer. In this case, if we're right in the middle, we'll get about 2.5 volts to the computer, and the computer will say, oh, we're like right in the middle of our range. Cool, we're probably cruising on the highway. Nice. If the air pressure changes, the voltage going to the computer is going to change. It's a variable resistor. These all talk to the computer. They give information to the computer. It'll tell the computer what's the air temperature outside, and it'll do that by giving a resistance value. It'll tell the computer what the air pressure is, and it'll tell the computer what the engine temperature is. Let's look at some mechanical things. Can you think of some things that are mechanical that the computer's going to need to see? Or can you think of things that the carburetor had to know in order to fuel appropriately? Yep. Throttle position. Nicely done. So we're going to have some kind of sensor that's like a throttle position sensor that tells the computer what's going on. Here's a throttle body. This part's connected to the gas pedal, so I can open the throttle. And directly across from it over here is the sensor. The sensor is just a variable resistor. As the throttle moves, this thing changes the resistance between the 3 pins here. One pin's going to have 5 volts, the other pin's going to have 0. The middle pin talks to the computer, and it'll give you a varying voltage. Cool story, bro. A kid a couple years ago had a Nissan pickup that he bought, and the couple that had it before could not drive the thing smooth, so they sold it for cheap. Kid bought it. He's like, well, I can't drive this thing smooth. What do you think it is? And I had a pretty good idea. I said, why don't we check that? So the schematic symbol looks like this. And we check, do we have 5 volts coming into the top? Yes, we do. Sweet. So it's getting the right voltage. Is it being grounded properly? Do we have 0 volts at the bottom? Yes, we do. Let's look at this. And we ran this into a voltmeter that went onto a screen so we could see what it's doing. And we're sitting at idle, and it was very low voltage, and this is a screen of time and a screen of voltage. And we moved the throttle with the key on and the engine off. We just moved the throttle open, and hippie shake shake! Oh, and then we move it back down, hippie shake shake! There's no way you can drive this. I don't care how stable and steady you are. If the computer sees this, regardless of what you are doing, if the computer sees this, the computer's going to go, okay, here's your fuel. That's what's the reality. Computers can only do what you feed it. If you feed it junk, it'll roll with that. What else could we look at in here that the carburetor needed to know about the fueling? Yep. I think it's about the amount of vacuum you have inside the engine. You're right. That sucks. So we're going to look at engine vacuum. However, we already have a guy who's looking at air pressure, so this kind of relates to this one as well. So let's draw a line up to here, and they're going to look at both. There's mechanical stuff and the environment. When we first start the car, the computer's going to sample air pressure and go, oh, you're in Colorado, okay. Or, ooh, you're at the bottom of Death Valley, okay. And it'll fuel accordingly. So that'll do our engine vacuum. What was the other thing that we were describing how the fuel went through a carburetor? Do you remember? Yep.
Mass air something something?
Yes, mass airflow. So we need to look at a mass airflow. We need to know how much air is going through the engine. So this is a mass airflow sensor. It's just kind of a screen with what look like itsy bitsy tiny little resistors or something way inside there, and they get a sense of how much air is going through it based on the temperature change it makes on the wires inside that. Not all cars use a mass airflow sensor. Some just use a MAP sensor and temperature sensors. Some use this. Is there another device? Can you think of another device in here? Something that we needed to know that was related to the fueling of the engine? Yep. What color it is? No. Yep.
No.
Okay. Some other thing we needed to know that affected the fuel. Yep. Is it going to be the speed of the engine? Nicely done. Yes. So we need to know how fast is this engine going and its RPM. We're going to call it something different. Some of your cars might have a tachometer in it that tells you how fast the engine is running. It would probably make sense that the faster I run the engine, the more fuel I'm going to need. If I'm running the engine really slow, I don't need a lot of fuel. So all of these talk to the computer as well. Now, let's say we have all of these inputs that are putting information into the computer. Now, what is the computer going to do? It's got to know, okay, if it's cold out, hot out, throttle's open, throttle's moving, airflow, vacuum, it's got to figure out what kind of fuel to give your vehicle. It takes in all of these and it'll look at what RPM are we at, what manifold pressure are we at, here's the fuel. But you know the temperature is going to change how much fuel you really need. And you know that air pressure is going to change how much fuel you really need. So while this can work, we can make it so much better by looking at this and doing math. And then make corrections. So it's like, okay, what RPM? What air pressure? Oh, but it's cold outside. And once it's looked up this table and made corrections, it will run our fuel. It's going to inject fuel into the airstream. But there's something you need to know about injectors. While all of this is now electrical, we took this junk, turned it into an electrical signal, and then we process the electrical signal by looking at a table, making some corrections, and we run the injectors. The injectors are completely mechanical. And they're actually pretty stupid, simple mechanical too. They only understand on and off. There's no in between. So how can I control the amount of fuel getting into my vehicle if I can only turn an injector on or off? Not like a little bit or a lot more. It's like freaking on and freaking off. How can I control the amount of fuel? You got some ideas? Yep. Could I just put less fuel through it? I don't know if that's going to work too well here. These are normally fed with high pressure, with pressurized fuel, and while we could change that, we don't normally do that. Any other ideas? No? Okay, I'll give you a hint. Wow, that was unexpected. Yeah? I don't quite get what you're getting at there, Mr. Wellwood. Okay, well, if you played a video game where you don't have a steering wheel, but you only have like left and right and left and right, and maybe you got to drive it, so you're like left, 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 right, 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 left, 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 left. You got to control your speed that way. You only have on or off. You don't have variable anything. If we can control the injectors by pulsing how much we turn them on or off, we might be able to control it. I have a question I don't even want to ask. What is it? Where did that even come from? That's beyond the scope of this lesson. Since we can only do on or off, what I need to do is turn it on and off at a certain kind of pulse. The $5 word you want is pulse width. Would you agree that if I turn the injector on and wait and on and wait and on, I'm going to have a very little amount of fuel compared to where I turn the injector freaking on and off for a teeny bit, freaking on, off for a teeny bit. More fuel is going to show up here and less fuel on there. If that's off, if that's closed and that's open, I'm only opening it a teeny bit. This is open a lot. So I can vary the amount of fuel that goes into my vehicle based on the pulse width. The pulse width is strictly math. Inputs, look up, do some math. Here's how much fuel you're going to get. The math is fairly involved. We don't need to do the math. All you need to know is this is what's going on. We're going to reference it, make some corrections, do this. Then our injectors feed the motor, and the motor burns it and runs it and carries on. And if we wanted, we could just leave it there and just carry on and it'll be fine. But this way, while it could be very precise and have some nice corrections, this way isn't going to be much better than a carburetor. We want to have more. And this is how fuel injection becomes freaking awesome. It's kind of like, it's like, how do you know? How do you know that you've got the right amount of fuel? I mean, you think you have it. Maybe the calculations were good. How do you know? How do you know what kind of fuel you have in there?
Do you know where he is?
Of course.
Do you know where he is?
Let's look at what we're feeding it. Would you agree that we're going to put into our engine fuel and air? Yeah. Yes. Yes. Okay, cool. What's the key ingredient in air that contributes to combustion? I think it's oxygen. I think you're right. So we got fuel and oxygen going in. Would you agree if I have lots of fuel going through, I should have very low amount of oxygen coming out? Wouldn't all the oxygen get burnt? Well, oxygen doesn't burn, but I know what you mean. We should be using all of the oxygen for that. But if I've got way too much fuel, I'm probably going to have a low amount of oxygen. What if I don't have very much fuel going through? It's running really, really lean. Not much fuel is going through. Would you agree I'm going to have a high amount of oxygen coming out of the tailpipe? Okay. If we had a way of looking at the exhaust that came out of the engine, we should be able to have a pretty good idea how we did on the fueling. And with that, we need this tool here. Again, where did that come from? Never you mind. This is an oxygen sensor, and it's used to look at the exhaust and see how well it's burning the fuel. Yeah? Kind of like looking at your own poo after a chili cheese enchilada burrito platter? Ew. Just ew. But ew. So yeah, this is going to look at the exhaust. If it sees an excess amount of oxygen coming through the exhaust, then we know we don't have enough fuel. So it goes and talks to the computer. And then maybe we see a small amount of oxygen come through. Well, clearly we have too much fuel. And this will talk to the computer. We get inputs, we look at a table, we do corrections. Open the injectors! Injectors go to the motor. How we doing? Egad, more fuel. Open the injectors longer. Run the motor, goes into here. How we doing? Egad, less fuel. Smaller pulse width. Goes to the motor. How we doing? More fuel. Bigger pulse width. How we doing? Less fuel. Smaller pulse width. How we doing? More fuel. Bigger pulse width. How we doing? Less fuel.
Business. Numbers. Is this working? Yes.
You can measure this and see the voltage change as it goes rich, lean, rich, lean, rich, lean, and it just corrects all the time. There's no such thing as a tune-up anymore because this does it while you're driving. It's constantly tuning. I don't have to change the mixture screws. I don't have to do none of that. This is doing it all automatically for us. It's awesome. It'd be pretty cool if you could put one of these up your butt and have a good idea of whether you're eating enough fiber. Ew, just ew. So I neglected to show you injectors, but let's do that now. In the early days of fuel injection, this was one way of doing it. This is called throttle body injection, where the throttle body has injectors. It's kind of like a carburetor in a sense. It's still electronically controlled and it's got all that wonderful doodads and gadgetry, but the injectors are here. Over here is where the throttle would be connected. This end has the throttle position sensor. Notice the 3 connections. One pin is positive, one pin is ground, one pin is going to have a signal. This thing's kind of cool. This would control your idle speed. In the bad old days when you tuned a car, you tuned it with the headlights on so that when the headlights were on, it didn't idle too slow and then stall in the dead of night when you don't have a good battery and then you're stuck with some guy on the side of the road with an axe. It evolved. And then we have just a basic throttle that has no injection at all. The injectors ended up being placed in the intake manifold at the port. Each intake port had its own injector, and this is called port fuel injection. Here's an injector. It's pretty simple. It's just a mechanical device, takes a bit of electricity, and it opens or closes. We put in high pressure fuel in here. Often they have a little tiny filter on the end, just to make sure we don't goo this up with anything. There'll be an electrical connection on there, and we just turn them on or off. There's no real in-between or nothing. So I've got a connection on there, and if I hook this up to a 9-volt battery, we should be able to hear it click. That's really all it does. It's either on or off, there's no in between, and they take a little bit of voltage. Here's a fuel injection computer that I have. Inside here, it's got a whole bunch of circuitry, a bunch of drivers to turn on injectors or switch other things, brains, stuff, magic, voodoo, the whole thing. I can connect a laptop to this and talk to the computer. These little lights, these LEDs, can give me some status of what's going on inside the computer. On the other end, all of these pins, the inputs all go into there, and then the outputs all come out of here as well. So this talks to the car, and the car talks to the fuel injection computer. Let's take a look at the vehicle this goes into. So this is one of my vehicles, and it's running Megasquirt fuel injection.
Giggity giggity goo.
Enough of that. This is a Toyota engine. Suzuki throttles from a motorcycle. I have injectors here. Down here is an intake air temperature sender. This is the throttle position sensor. This one's taken from a GM because the Suzuki throttle position sensor was doing the hippie shake shake like no man's business. And the computer was like, okay, here's your fuel. And it was almost impossible to drive. The connection with the green clip is the engine coolant temperature sensor. The sensor with the gray clip is the temperature gauge on the dashboard. And the unconnected sensor would turn on a cold start injector. So in the old school days when this Toyota was fuel injected, there was an extra fifth injector to give you more fuel when it's cold outside. Here on the front of the motor, you can see a toothed wheel and a little sensor down there at the bottom, which senses the tooth going by. Every time the tooth goes in front of the sensor, it sends a voltage pulse to the computer, and then the computer knows, okay, there's 36 teeth on here, one tooth is missing. I know top dead center is where the one tooth is missing, and then it can give me a pulse for RPM. I notice I have a coolant leak. That's disappointing. So this is my tuning software. It's plugged in through a cable up to the computer underneath the dashboard. So now we're running. What we're looking at here is the enrichment for when the engine's cold. So it's giving me right now about 125% fuel. It's cold. The engine's not up to temperature yet. We want to be at 190 degrees. It's not up to temperature. It's giving me more fuel. This is my table. Down to the bottom is RPM. This is what would normally be atmospheric pressure. Total vacuum. This would be high vacuum, throttle closed. Up here would be full throttle. These numbers are not kilopascals. Don't worry about that. But right now, I'm fueling with this. If I rev the engine up, it's going to work its way and pick different kind of fuel. It's got a bit of a stumble right there. Yeah, it doesn't like being there. Let's give this maybe 25 units of fuel. A little better. Let's go maybe 30. Yeah, seems a bit better already. It's not happy here. Don't know why that's 20, 17, and 30. Let's change that one to like 25 and see what it does. Yeah, it's better. This just takes time to tune it. This isn't normal. Most people don't do this. This is not a normal way of doing things. However, right now that's my air-fuel ratio. It's about 12 because remember it's cold, it's rich, and this vehicle doesn't really like to run particularly lean. It's certainly not warm enough yet. We're going to talk about spark advance, the next unit. Throttle position. Pulse width. When I rev it up, the pulse width increases. When I blip the throttle, it gives me a whole bunch more fuel so it doesn't stall. Ah! I've lost it. Coolant temperature coming up. Engine RPM still low. Right now we've got 45 kilopascals in the engine. Still needs some tuning though, but there we are. Cool beans. We should take this for a drive. Oh yeah. Hey, now we're in my wife's older Infinity. And I've got a scan tool. You can get these for pretty cheap. 30 bucks, 100 bucks, whatever. I think I paid 35 bucks off of eBay for this guy. Relatively easy to use. Hopefully this shows up on the screen. I can look for any diagnostic codes. Are there any check engine lights? We have no check engine lights. Yay! Oh, let's look at live data. That's always fun. And this is going to talk to the computer inside the car and give us an idea what's going on. So there's my engine temperature at 36 degrees Celsius. These are fuel trims where the engine is like adjusting. Let's say the engine the computer figures the engine's just consistently too rich. It'll start doing short-term or long-term fuel trim to retune itself. Here's my RPM. Vehicle speed sensor. I'm apparently sitting still, which is good because I'm parked in my garage. This is my spark timing. Which we'll cover in the next unit. There's the grams per second of mass airflow. My throttle position is 2. I just revved the engine a bit. Now it's seeing 4. These are my oxygen sensors, voltage. 0.5 of a volt would be a good mix. This is 0.3, so it's running a bit rich. Makes sense. This engine is not hot. I just started it up. Check engine lights just come kinda like this. How old are you? I'm 17. Nice. Would you date an 18-year-old? Why, yes. How about a 19-year-old? Yes. How about a 20-year-old? Yes. 40-year-old? No. All right, so where would be your top limit? 37. Okay. Now, we go down here. Would you date a 16-year-old? Why, certainly. Would you date a 15-year-old? No. Awesome. So here's this is your dating range. You go to a party and you meet a girl and she's like 18 and you check and go, yep, 18, that fits, good. You date. Inevitably, she dumps you. Then you go to another party, you meet someone, she's 20, you're like, all right. And it goes for a while and it's pretty cool and it could be exciting. And then she dumps you for somebody else. Find another girl at a party and she's 12. You should have a bright red light on your dashboard saying, that's prison, I should not go there. And you need to have that. This is your range of acceptable. This is not acceptable. If you find some incoming data that's outside of the acceptable, that's when your check engine light comes on. You bet your butt you've got a check engine light showing up. If you're accepting this, you need a malfunction indicator lamp. You need some serious counseling if that's where you're going on this. Stay with the acceptable. So you want a check engine light, a malfunction indicator lamp, something to say, this is wrong. You need to get that looked at. Sometimes it's just a light that shows up. Other times it could be a disastrous thing and your car will go into limp home mode where it drives like crap, but it'll get you home. Kind of like if you do date that girl and her father finds out, you're gonna go into limp home mode if you can move at all. That's where kind of check engine lights happen. Thanks for watching. Stay in school, don't do drugs.
I'm here all week.